Well, at some point, you have to admit there's some very cool, bizarre diseases out there. There's all sorts of exotic ones that are, on a certain level, just irresistible. There's Elephant Man syndrome. There's multiple personality disorders. They're the sort of diseases that get turned into the movie of the week. There's this really bizarre one, a disease called Kuru, which is only found amongst cannibals in the New Guinea highlands, and it produces a disease a little bit like mad cow disease, and it is transmitted by eating the brains of somebody. And these are cool, bizarre ways in which biology can go wrong. If you want uncool, unbizarre, meat and potatoes disease versions of just profound human sadness, there's nothing out there like a major clinical depression. Depression. As we transition here, slowly over the recent lectures, moving from the world of your heart, your liver, your kidney, now moving into the realm instead of your psyche, your psychiatric status, we've been making this transition, beginning in the last few lectures, to see what does psychological stress comprise and how powerful can it be. This is a clear transition to what we will focus on in this lecture, the starts of psychiatric disorders, ones that are absolutely deeply intertwined with depression. Now, depression, it's going to be 2 lectures worth of material to cover, and this is for a number of reasons. First off, complicated subject, and there's actually an awful lot known about the biology of depression. Second reason, that there are oceans of people out there with major depression. Current estimates by the World Health Organization is that depression is the number 4 leading cause of disability on this planet, and the estimates are by the year 2020 that is going to be up to number 2, following things like metabolic syndrome, those disorders we know about by now. So complicated, so it takes a lot of time, incredibly prevalent, so it's really worth going into. And another reason why it's really worth going into, it is a disaster of a disease. And I will make the argument in here that a major depression is among the worst diseases anybody could possibly suffer. And we'll see why I think that. Okay, what we'll be doing in this lecture is starting off in one domain of understanding depression, understanding the biology of depression. And after an initial part of focusing on what the symptoms of depression are, some of which are absolutely intuitively obvious and some of which are quite surprising, after that introductory stretch, we will begin to focus on what is the biology of depression. What is the brain chemistry? What's the brain chemistry that goes wrong? What are the structural features of major depressive brains which wind up being abnormal? Transitioning into the next lecture, what hormones are out of whack? What do hormones have to do with depression? Perhaps even nutrition. At that point, what you will have is everything needed to be a cutting-edge biological psychiatry maven. You'll know about hormones and neurochemistry and neuroanatomy, and what we will see at that point is, if that's all you know about the subject, you don't have a prayer of being able to do a whole lot to contain depression. What we'll transition to at that point is the other half of the equation. What are psychological factors, and how are they part of the whole process of clinical depression? And what you're going to see there is what seems to be at the end 2 completely different worlds, different languages, the world of depression as funny neurochemicals and hormone ratios, the world of depression as problems with a sense of control, a sense of despair. What we're going to see is the way these 2 very different views are pulled together is by recognizing the absolutely essential role of stress. Now, what will run through all of this, and is implicit in the very subject of this lecture, the biology of depression, winds up being one of the things that is challenging when dealing with depression, which is there's a weird sort of moralistic thread that runs through how people think of depression, where it's almost a sense of, well, hey, we all get depressed. bad things happen, we get depressed, we feel lousy, and we come out the other end. Depression is this disease of people who don't quite pull it together, who kind of indulge themselves. There's a weird tinge of sort of moralistic judgment about a depression. What will be a main theme ultimately in this and the next lecture is depression is a disease. It is a disease. It is real of a disease, as is diabetes. And you don't sit down a juvenile diabetic and say, oh, what's the deal with this insulin stuff? Stop babying yourself. This is a real disease. So we start off by looking at what depression looks like. And we start off immediately with a semantic problem, which is we use the word depression, again, in an everyday sense. Oh, something disappointing occurs, something that sort of gets you down. You get depressed. Oh, I've been feeling depressed. It was a depressing day. That sort of thing. When talking about a major clinical depression, this is not, oh, feeling kind of down. This is a disorder where you are so crushed by the sense of depressiveness that you can't get out of bed, that you don't, do laundry for months on end, that your entire life is ruined, you can't get out of your house, you can't function, you can't work, you don't see anyone. It is a disease that absolutely cripples you. So what are the symptoms of major depression? As I said before, I think major depression is among the worst diseases that can possibly happen to you. And it's because of this main symptom. Think about a remarkable feature of humans. You get somebody with a nightmare of a disease, with cancer, terminal cancer, and to a surprising extent, people will wind up saying things like, obviously I didn't want this disease and don't want to die, but it wasn't until I got the cancer that I realized how important family is to me, or what good friends I have, or I found my God, and I almost feel grateful for it. We humans have this bizarre ability to find pleasure in the most unlikely places. And the defining symptom of depression is it's a biochemical, genetic, environmental disorder where you can't appreciate sunsets, where you lose the capacity to feel pleasure. This is the core symptom, anhedonia. Hedonism, the pursuit of pleasure, anhedonia, the inability to feel it. So, moving on, and getting a sense here of the sheer severity of depression. Along with that lack of pleasure, the anhedonia, there is deep grief, deep guilt. And this, again, is not like everyday depression. Ooh, you feel kind of down about something, you sort of grieve about something going wrong, some transient failure. When we're depressed in the everyday sense, we tend to obsess over things in the past that we feel guilty about. Again, this is not what major depression is about. It is such severe in the elements of grief and guilt that at an extreme, it could even take on a delusional quality. This is not delusional in the way a schizophrenic might be, but it's delusional in the sense of how you interpret the world around you. Let me give you an example. Older guy, perfectly healthy, and one day from out of nowhere he has a heart attack. He's in the hospital. He's recovering from it. The reality is that he is going to recover and his life can pretty much get back to normal, but he falls into a major depression as a result. So he's in there every day, getting a little bit stronger, and every day talking about how he's falling apart, he's declining, he's going to die, there's no hope for me. It happens, the hospital is circular, and the nurses get him up, and as he begins to get some strength back, he's able to walk one loop around the hospital. That's great. The next day, getting stronger, he walks 2 loops around. That evening, his family is there, and he's going on yet again about, oh, I'm dying, I wish you could at least tell me the truth, and they'll say, you're just depressed. You're getting better. Look, we heard from the nurses. Today you did 2 loops around the hospital, and yesterday you did 1. And he'll say, No, you don't understand. They've been doing construction. They've been doing construction here at the hospital, and they had to close down the main corridor, and they had to make a new, shorter one, a little one last night. So 2 loops around that is, in fact, a lot shorter than the big one, and I'm falling apart and I'm dying. This is delusional thought. And this was actually an engineer, the father of a friend of mine, an engineer going on about angles and diameters and radii and expecting them to believe that last night the folks came into the hospital like little beavers, dug out this. This is delusional thinking. And it's sufficiently so that there's this view, the typical view, that depression is a disease of emotion. Ultimately, it's also a disease of distorted cognition. You view the world around you and you so intensely see the glasses as half empty, even the ones brimming over the top, that there's ultimately a cognitively distorted, even delusional quality to it. What are some of the other symptoms of depression? Of course, the one that is among the most horrifying is the tendency of people, when highly depressed, to injure themselves, to mutilate themselves, to attempt suicide, to succeed at committing suicide. And it happens with a very high rate. The current numbers are about 15% of people will come down with a major clinical depression at some point in their lives, and a substantial subset of those people will be depressed enough at various points to feel suicidal. Not good. This is horrifying on a certain level. What's the self-injury about? It begins to tap into a subject we'll hear about later when we begin to look at the psychology of depression and a notion that depression has something to do with unresolved angers. We're going to see about that. There's some pluses and minuses to this one, but there's a soundbite that came out of that literature. Depression is anger turned inward. And the self-injury component of that certainly makes sense. What else goes wrong with a major depressive? You have social withdrawal. That's an obvious extension of the anhedonia, loss of libido, an obvious extension as well. But then you get a whole bunch of symptoms that are fascinating, a whole bunch of changes in the body of a depressive. These symptoms that are collectively called vegetative symptoms. For example, sleep changes during a depression. What's your guess? Well, when most of us are kind of feeling depressed for some period, we tend to sleep more, we're just without energy. And no, people who are clinically depressed, majorly so, the tendency is to sleep less. Okay, they're depressed, they have trouble falling asleep. No. The tendency instead is to fall asleep fairly normally, but wake up really early in the morning. Wake up at 4 in the morning, and you are awake, and you are not remotely rested, and that's it. And come into an emergency room someday with a deep, incapacitating depression, and one of the things they better ask you is, so do you wake up early in the morning? Early morning wakening, that is a real clear marker of the disease. Next, when you actually do fall asleep, we've learned already from the previous lecture, there's a whole structure and whole architecture to sleep, the different sleep stages, slow wave sleep, REM sleep. It tends to be about 90-minute cycles. You look at the brains of depressives when they're sleeping, and the structure, the very architecture of their sleep patterns is disorganized. Indulging yourself, absolutely no way. This is someone who, when they're asleep, their brain is working differently. More abnormalities, a change in appetite. In most people, decreased. In a subset of people, increased. A change in all sorts of aspects of metabolism. And for our purposes, probably the most interesting thing, in a substantial percentage of depressives, increased levels of glucocorticoids. And what that screams to you is stress, and as we'll see, that makes perfect sense. And what that screams to you, I hope, is this is a biological disorder. There's hormones that are out of whack, sleep cycles. This is not stop indulging yourself. Now, another feature of depression also screams biology. And this is the fact that there's patterns to when people have their depressions. There will be a person with a cycle of being symptom-free for a certain amount of time, fall into a deep depression, come out the other end at a certain schedule. There can be rhythmicity to the disease. And the most striking example of that is people who get depressed, more likely, at only a certain time of year. And it tends to be the winter months. This is someone who, in July, things are going perfectly fine, and then something disastrous occurs, and they feel depressed, and they come out the other end, they cope, they heal, and along comes January where there is nothing wrong whatsoever, and just like the previous 6 Januaries, they fall into a winter depression, and they have to be hospitalized, and there's this rhythmicity. This particular one is referred to as a seasonal affective disorder, affect, emotion, seasonal affective disorder, SAD, and this is another thing that screams biology, the biology of rhythms, daily rhythms, seasonal rhythms, and there's something wrong with those rhythms. This is not, ooh, stop babying yourself. This is a disease that's all about biology. So this transitions us now to asking, what is wrong biologically in depression? And where we start off is brain chemistry. What's going on normally, and what's going on that's not quite normal in the brains of people with depression. Now, this is best covered in a diagram, which you could find in the guidebook, and this is one that shows the basic flow of information between 2 neurons, 2 brain cells. Now, you'll remember from the earlier lectures, one neuron will send a projection, a cable to another neuron, and that's what was going on in the spinal cord, the fast, acute pain, the chronic pain, all of that. In actuality, that projection from one neuron to the next doesn't actually touch the next neuron. There's a little space in between called a synapse. Synapse, that's what a synapse is. It's a tiny space between 2 neurons, and what that means then is if a neuron is going to talk to the next neuron, it releases a chemical messenger which goes floating across the synapse. It comes out of this end of the neuron. It comes out of the extreme end of the neuron, what's called the axon terminal, and it floats across this tiny distance to what's called the dendrites of the next neuron, goes across, and yes, indeed, as we know by now, that neurotransmitter will interact with its neurotransmitter receptor, and suddenly something or other changes in that second neuron. The 2 neurons have talked to each other. Something or other, as we saw in the pain lecture, something or other sometimes could make the form of making the second neuron more excitable, sometimes less excitable. The neurons are talking to each other by way of these neurochemicals, neurotransmitters. Now, looking at that, there's one additional piece that you have to make sense of, which is the first neuron has released these neurotransmitters across the synapse. They bind to the receptor, they do their thing there, and they come floating off the receptor. And then, you got to clean up after yourself. You've got to finish what you've done. You've got to get rid of the neurotransmitter you released, and it's floating around now. And there's 2 options. You could be ecologically minded. You can recycle your neurotransmitter. It is taken up by a fancy pump in that axon, the end of the neuron that released it. It's taken back up. It's repackaged, ready to be used again. Or you can really be unecologically minded. You can throw out your neurotransmitter. There might be some enzyme in the synapse that takes the neurotransmitter, rips it into a lot of little pieces, flushes it down the toilet into your cerebral spinal fluid and such. So we've got this general role of neurochemical communication, which is a neuron, when excited, releases a neurotransmitter, floats across the synapse, stimulates the next neuron by way of binding to its receptor, comes floating off, at which point you finish the whole thing either degrading the neurotransmitter or recycling it. So this is the general rule about neurotransmitters. And amid these general rules, there's a gazillion different chemicals that appear to be neurotransmitters that meet at least some of the criteria for them. And what we now know, and what was sort of the first bit of information in the depression field, is there's something screwy with a neurotransmitter called norepinephrine. Wait a second. I've heard the name norepinephrine before. Oh, so many lectures ago, that sympathetic nervous system releasing epinephrine, norepinephrine down at your heart. this is norepinephrine in a different part of your nervous system doing something completely different that has something to do with depression. You can use the same letter in all sorts of different words. You can use the same chemical messenger. So there's something wrong with norepinephrine in a part of the brain that has something to do with pleasure. And the absence of norepinephrine gets you into trouble there. Stay tuned. We'll see that area in a bit. So what's the evidence that there's something wrong with norepinephrine? You go back to the very first drug that was developed as an antidepressant. It's called an MAO inhibitor. Do not worry, this MAO inhibitor, the name will make sense. In the synapse, there's an enzyme which rips up norepinephrine into little pieces, it degrades it, that whole thing you just heard about, called MAO, monoamine oxidase. MAO, and what does an MAO inhibitor do? It inhibits MAO. And as a result, you don't rip up the norepinephrine afterward. It sticks around longer. It sticks around longer, and it's got nothing else to do, so it might as well hit that receptor on the next neuron a second time, and a fifth time, and a 20th time. And what happens then is you are sending more norepinephrine signaling. And depressives tend to get less depressed at that point. So what's your hypothesis at that point? What does it have to be? Ooh, if throwing in a drug that increases norepinephrine signaling makes depressions less depressive, maybe the initial problem is a paucity of norepinephrine. And this gave rise to the norepinephrine hypothesis that there's a shortage of norepinephrine in one relevant area of the brain as the cause of depression. More evidence rolled in. By the 1960s, 1970s, a next class of antidepressant drugs had become popular called tricyclic antidepressants. And it turns out they do essentially the same exact thing. They don't work on MAO, which rips up the norepinephrine. Remember that other step where you can also recycle it? The first neuron takes it back up and repackages it. What do tricyclics do? They block the reuptake. They block the reuptake, and thus the norepinephrine sticks around in the synapse longer, and for lack of anything else to do, hits the receptor a second, fourth, 50th time, and the person gets better. Ooh, yet another way of increasing norepinephrine signaling, and depressions get less depressive. I bet there was too little norepinephrine. More evidence, there's a drug, it's used very rarely now, but there's a drug that lowers blood pressure called reserpine. And what does reserpine do? It destroys some of the packages of norepinephrine at the ends of neurons. There's axons. Neurons release a lot less norepinephrine. Back to the sympathetic nervous system, less norepinephrine on the scene. Blood pressure is going to decrease. That's great. But there's the side effect, which is if you get the levels too high of this reserpine and you wipe out too much norepinephrine, the person gets clinically depressed. So we've got bidirectional evidence here. Take drugs that push up norepinephrine levels, and you take depressives and they get better. Take drugs that drive down norepinephrine levels, and you take undepressed people and they get depressed. So yes, I'm convinced by now. So what does a shortage of norepinephrine cause in the brain? Or flip the other way, what does norepinephrine normally do? And amid its roles, all sorts of things, you've got a very interesting role for norepinephrine. It's got something to do with pleasure. Back in the 50s, researchers, neuroscientists, discovered something very interesting. They found this one area of the brain, the limbic system, where if you put an electrode down in there in a rat's brain, and here's what you did, you set things up so the rat could press a lever a certain number of times, and by doing that, it would get buzzed in that part of the brain. And this buzzing, this stimulation of this part of the brain caused rats to be unbelievably happy. So, of course, the question is, how can you tell when a rat's unbelievably happy? It will just press the lever over and over and over. Rats would work themselves to death in order to get stimulated in this part of the brain. And it was soon called the pleasure pathway. It's got more technical terms. But as soon as people saw this, of course, the question is, do you find this in humans? Do I have one? Can I get a new one? Can I get a second one? And soon, neurosurgical studies with humans in the process of going in to get out a tumor, for example. In classical neurosurgery, people would be awake, and so studies were done stimulating those areas, and it would generate a pure, absolute sense of well-being. That's great. So now what do we have? the next finding, which was that that pathway makes heavy use of norepinephrine. Aha! So you got a shortage of norepinephrine in this pathway. This pleasure pathway is not working very well. And suddenly, what have you just generated? Anhedonia, that defining symptom of depression. So that's great. That describes everything. That explains it. It's all about norepinephrine. Here's where the problems come in. 3 reasons. First one is you throw in norepinephrine into one of these neuronal systems, and it starts changing what's happening. You throw in, one of those antidepressive drugs, tricyclics, monoamine oxidase inhibitors. You throw in one of those, and within minutes, they're changing stuff going on in the synapse. You throw them into a depressed person, and they don't start feeling better for 2 to 3 weeks. Something doesn't fit. Next problem. People soon learned that, yes, norepinephrine had a role in those pleasure pathways, but they soon discovered another neurotransmitter played a much more critical role, dopamine. And then came along the drug that really messed things up, a drug like Prozac. Prozac, which is an SSRI, a serotonin, a selective serotonin reuptake inhibitor. This one works just like the tricyclics. It makes it impossible to take back up the neurotransmitter, but it was a different neurotransmitter, serotonin. And suddenly, the norepinephrine hypothesis wasn't looking all that exciting and very flawed there, and people punching it out. And you want a resolution at this point, a very, very simplistic one in terms of what's going on with norepinephrine, serotonin, and dopamine during depression. Here's an extremely, extremely simplified one, and don't hold me to this. Norepinephrine has something to do with energy. The absence of norepinephrine begins to explain the psychomotor retardation of depression. It's exhausting to do everything. Serotonin has something to do with this rumination on grief, despair, guilt, and the shortage of dopamine has something to do with the anhedonia. Super simplistic. Okay, so we've now gotten a bit of a sense about the neurochemistry. Very quickly looking at something about the neuroanatomy of depression. We already know one thing, which is the hippocampus tends to get smaller. That's not what we'll focus on here. Instead, we hark back to many lectures ago, that triune brain concept. You've got that ancient reptilian brain that does mechanical regulatory stuff. You got the limbic system superimposed on top, and then you've got the cortex abstract thinking. Think for a second what a depression is about. Sad things, sad thoughts, sad memories, sad emotions. Go out and once again get gored by a rhino, and you're going to turn on a stress response. You will secrete glucocorticoids. You will not feel like having sex all that much. Growth will probably be delayed. Sleep will be disrupted. Sit there instead and think about children in refugee camps. Think about childhood leukemia. Think about any of those things, and suddenly your body does something similar to that with vegetative symptoms. Up go glucocorticoid levels, disruption of sleep, anhedonia, all of that. On a certain level then, what is a depression? A depression is when your cortex comes up with some abstract, sad thoughts and manages to get the rest of your brain to go along with it as if it was a real stressor. What the cortex is about is the abstractions, the very, very subtle, poignant features of what stresses us, of what saddens us, of what depresses us, where it is then able to send projections down to those ancient reptilian areas, as we heard earlier, and stimulate them into a stress response. Okay, this is very simplistic, obviously. And now let's take this one step further with really an idiotically simplistic idea. Okay, so if the problem with depression is you got your cortex thinking, ooh, too many sad thoughts, and whispering it down to the reptilian part of the brain and kicking things into gear there, what's the cure for depression then? Take yourself a little pair of scissors and cut underneath the cortex and disconnect it from the rest of the brain. Oh, that's really a terrific therapy. That's really going to do a whole lot for you. Remarkably, a version of that, which is used in very, very rare circumstances of severe intractable depression, actually makes people feel a bit better. Something called a cingulum bundle cut. And that supports this notion of the cortex coming up with sad ideas. Okay, it's not just the cortex, it's a sub-area found very much intertwined with the frontal cortex, an area